Okay, we're on page 4. All right, on page 4, we are going to identify triangles. We're going to classify them, name them. On this side, we're going to name them based on the angles. Okay, so on this side, we're going to be looking at the angles of a triangle. Now, a couple weeks ago, you learned what makes an angle: acute, obtuse, right, and straight. Today, we're going to learn what makes a triangle: acute, right, and obtuse. There's different things. All right, so number 1, what makes this triangle, these triangles I should say, a right triangle? So look, investigate, look at these triangles on your paper. What makes these right triangles? How many? 1, exactly. A right triangle has one right, otherwise known as 90 degrees, angle. Okay, so if it has one right 90-degree angle, you call the whole triangle a right triangle. So as soon as you have one, everything is called a right triangle. Yes?
What's the wrong triangle?
We don't talk about that one.
What's the left triangle?
No, it's no bueno.
Oh. How about the middle one?
All right. Okay. Now we're going to talk about an acute triangle. That's not a right triangle. It's an acute triangle. Here are some examples of an acute triangle. Here are some examples of not. What makes a triangle acute?
It's less than 90 degrees.
What is?
It has a very pointy edge.
How many? All of them? 2 of them?
It's thin. Well, it's
Oh, wait.
How many are acute?
3.
Yep. So an acute triangle has 3 acute angles. Has 3 acute angles. See, all of these are smaller than 90. All of these are smaller than 90. All right. An obtuse triangle. Let's look at an obtuse triangle. All right. What makes a triangle an obtuse triangle? Okay, sorry. What makes it obtuse? An obtuse triangle has one obtuse angle. Has one obtuse angle. So this was the obtuse angle right here, and this one's the obtuse angle. Just one. Can you have a triangle that has 2 obtuse angles? Can I start drawing a triangle that has 2 obtuse angles? No. It's not possible. Okay, so this is based on the angles. So it's kind of like what we've already learned, but now in a triangle form. Okay, now we're going to turn the page.
Is that a quadrangle?
Quadrilateral?
Quadrangle?
No, it's quadrilateral.
Quadrangle.
All right, next page. Now we are going to base it on the sides. We are going to base it on the sides. Now this has a lot of new vocabulary words. The first new vocabulary word is called the scalene. Scalene. These are examples of scalene triangles based on the sides. What makes a triangle a scalene triangle based on the sides? Who wants to take a wild guess? What makes this triangle a scalene triangle based on the sides?
They're all different sizes. They're all uneven.
They're all uneven? What's another word for uneven? Because uneven would be like, what do you mean uneven? What did you say, Richard?
I forgot. They all have different measurements?
Different measurements, exactly. Not the same. Uneven could be like, are they not 2, 4, 6, 8? Is it like a wonky, doesn't close triangle? So a scalene triangle has no equal sides. Okay? All the sides have different measurements. All the sides have different measurements. Write this down. These are the definitions to these vocabulary words. Scalene is your new vocabulary word that we're going to be using. Scalene is the new vocabulary word. All right. Number 5. Isosceles triangle. Isosceles, a new vocabulary word. But we got to cross this triangle out. It's actually in the wrong place. Okay. Other than that one that we just crossed out, what makes a triangle an isosceles triangle?
2 symmetrical lines.
Oh, with the vocabulary. Yes. 2 only has 2 equal sides. 2 sides are equal. 2 sides are congruent. 2 sides are equal. Okay, so you guys see these funny looking dashes?
Yes.
That means that they correspond to each other, equal to each other, equal to each other. So these 2 are equal to each other. Those 2 are equal to each other. So isosceles has 2 equal sides. Here's how I remember the difference between isosceles and scalene, because they're 2 weird words. When I draw a capital I, how many lines are equal in a capital I? 2. The top and the bottom are supposed to be equal, right? So that's how I memorize that isosceles is 2 equal sides, because the I has 2 equal sides. Isosceles, 2 equal sides. Okay? Okay, there's one that was not written in this packet. Don't know why. And it is called, does anybody know what you call a triangle that has 3 equal sides? 3 equal sides? All right. Equilateral.
Oh, wait. Oh.
Yes.
Oh, no, wait, no, that's a quadrant.
Equilateral triangle. It even has it in the name. Equilateral. It's the one you crossed out. Equilateral triangle. All sides are equal. All sides are equal. Equilateral triangle. All sides are equal. It says it in the name. Equilateral. All right. So, for a triangle, you need a first name and a last name. You need a first name and a last name. The first name is acute, obtuse, or right. The last name is scalene, isosceles, equilateral. So your triangles will always have 2 names. Just like you have 2 names. A first name and a last name. Your triangles will also have a first name and a last name. Got it? All right. Go back to page 2. Yeah, to page 2. Page 2. Page 2, page 2, page 2. Okay. Wow. Why are you so behind? What happened yesterday? Were you here yesterday?
I left earlier.
Okay. Thank you. I was like, what happened? ¿Qué pasó? All right. This one. Look at the sides. 3, 5, 7. Are any of the sides equal? No. So no equal sides. You see that? 3, 5, 7. So let me turn back. What do you call it when it has no equal sides? Oh, scalene. So what do we call this triangle? Scalene. There's no way I can name them without looking back at my notes. Scalene. Okay. That's the sides. Now let's look at the angles. What kind of angle is that? Acute, obtuse, or right? That one is?
Obtuse.
So that one's more than 90 degrees?
Yeah.
Stop. You need to stop. This one is what? Is it more than or less than 90? Less than. So this one is acute. What about this one over here? Acute. So I put little A's to signify that they're acute. This one's acute. This one's acute. Now this one, it's hard to tell. So I'm going to rotate my paper. This one right here. Cover of everything. If I cover it, it's kind of easier to see just the angle. So, is that acute, obtuse, or right? That one's obtuse. If I use a protractor, which I'm going to give you in 30 seconds, do you guys see how this angle is more than 90? Right there. So this one is obtuse. So what do we call a triangle that has acute, acute, and obtuse? Well, let's look at page 4. Acute has all 3 acute angles. Obtuse has 1 obtuse angle. So what do we call it? Obtuse. How many obtuse angles does it have? 1. It only needs 1. It's so powerful that it only needs to have 1 to call itself obtuse. Acutes are small and less powerful. They need all 3 of them to be acute, to be named acute. All right, can you name number 4? Can you name number 4?
Oh, yeah, I got it.
I would recommend watching the video from yesterday.
Right now?
Yeah.
Fine.
Because you don't know you know how to do this. You don't know how to use the
No, I
tool. Okay, then draw me this triangle. All right. What did we name number 4? Scalene. Whoops. Scalene what? No. Did you measure all the angles? This one's acute. This one's acute. But this one. Use your protractor and see what you will get. What do we mean? All right. If you actually took the time. So on Friday, when you have your quiz, I'm going to give you like problem number 4. And I'm going to say, draw it and name it. Now, are you going to take the risk of like, oh, I think that's acute, but I'm not really sure. Take the time, use your protractor, and figure it out. Is it acute, right, or obtuse? Agustin, what's your question?
How do we get the
Okay, can you guys name 5, 6, and 8, please? 5, 6, and 8. So after you're done with page 2 and 3 naming it, I need you to go to page 6 and draw out numbers 1 and 2 at the bottom and name them.